Okay, guys. So for this is a discussion, recorded discussion about the blood gases, pH, and buffer system. Although I know that it is easy for you to understand the PowerPoint presentation that I gave you. That's why I already gave you the PowerPoint presentation for you to read it and for you to analyze. However, um, others might not for others, since we have different learning capabilities, they may find it difficult to understand. That's why I'm making this recorded discussion. Okay, so I hope you find time to listen to it, okay, before your prelim examination. It's always up to you if you want to do it that way. Or you can just review the PowerPoint presentation. Either way, it's your choice. Okay? So when we say an acid, that is a substance that can yield a hydrogen ion concentration, okay, or hydronium ion when dissolved in water. Sa usapan natin ngayon, when we say acid, it refers to hydrogen ion. Kapag base naman, okay, that is a substance that can yield hydroxyl ions. Okay, hydroxyl ions. But mostly of the next slides, so yung base natin dun is si bicarbonate. Although this is the textbook definition, that is a substance that can yield hydroxyl ion. So si bicarbonate kasi it can yield hydroxyl ion naman. That's why that is, though it is a weak base. Okay. So the relative strengths of acids and bases, their ability to dissociate in water, are described by their acid dissociation constant. Okay? So, this is the acid dissociation constant, or pKa. So the acid dissociation constant, that is defined as the negative log of the ionization constant, is also the pH in which the protonated and unprotonated forms are present in equal concentration. Okay? So negative log siya, which means yung concentration, so dito kasi sa acid dissociation constant, we are referring to the hydrogen ion. Okay, so acid siya. So negative log. Ibig sabihin din nun, there is an indirect relationship, indirect proportion, indirect relationship ng H ion to the pH. Kapag mataas ang H ion, okay, mababa ang pH kasi acidic siya. Pero kapag mababa ang hydrogen ion concentration or yung H+, ano ang pH mo? Pag mababa yung hydrogen ion concentration, mataas yung pH mo. More on the alkaline siya. Kasi nga mababa yung acid na present. Okay? So, ganun siya. Strong acid, that is, it has an acid dissociation constant less than 3, greater than 9 naman kapag yung mga strong bases. So, yung mga strong acids natin and strong bases, ito na yung mga chemicals that we have in the chemistry laboratory, kagaya na lang ng mga sulfuric acid natin. Okay? Sulfuric acid, hydrochloric acid, those are very strong acids. Okay, for acids, raising the pH above the acid dissociation constant will cause the acid to dissociate and yield a hydrogen ion. Okay? So for bases naman, lowering the pH below the acid dissociation constant will cause the base to release what is this one again? Okay? Kahit ako na. Okay, so that is the hydroxyl ion. Okay, so ako din nakakalimot. Many species have more than one acid dissociation constant, meaning they can accept or donate more than one hydrogen ion. So buffer, when we say buffer, we already defined this one in your biochemistry, even in analytical chemistry, that is a combination of weak acid and a weak base. And its action is that it will try to resist a change in pH. Okay, but guys, take note that the effectivity of the buffer depends on the acid dissociation constant of the buffer. Okay, magdedepende yan sa pKa or acid dissociation constant ng buffer at saka yung pH ng environment, okay, in which the buffer is placed. So, for example, meron kang solution dyan, okay? So, gusto mo siyang lagyan ng buffer para i-resist niya yung change. Kung meron kang ilalagay na mga solution or meron kang ilalagay na chemical. Pero yung effectivity ng buffer, magdedepend siya sa acid dissociation constant ng buffer at saka yung dati ng pH nung solution mo. Okay? So in the plasma, the bicarbonate carbonic acid system having an acid dissociation constant of 6.1 is one of the principal buffer. So, principal buffer si bicarbonate carbonic acid system. So acid-base balance, maintenance of hydrogen ion concentration. So the normal concentration of hydrogen ion concentration in the ECF, the extracellular body fluid ranges from 36 to 44 nanomole per liter. But the body produces much greater quantities of the hydrogen ion concentration. So that actually dapat yan is H+, diba? Hydrogen ion. Any hydrogen ion value, so eto nasa baba siya, pero that is H+. Dapat nasa taas, diba? So ganun naman yung paglalagay ng charge. Any hydrogen ion value outside this range will cause alteration in the rates of chemical reactions and blah 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 that may lead to alteration sa consciousness, neuromuscular irritability, tetany, and coma and death. Okay, that's why maintenance of the hydrogen ion or the acid-base balance is very important in the body. Kaya si body naman, yung katawan natin, meron naman siyang ginagawang compensation. Okay? So, it will try to compensate para mabalance pa rin yung acid concentration sa ating katawan. So, the acid-base balance maintenance of hydrogen ion that is done by two major organs. Okay? So, dalawang organs ang nag-maintain ng acid-base balance. Si lungs and si kidneys. Okay? So, another factor that contributes to maintaining the acid-base balance, of course, yung mga buffer system natin. So, si lungs, si kidney, si buffer, sila yung nag-maintain ng acid-base balance sa katawan. Okay? So, minemaintain nila ang correct pH. Okay? So, we have term acidosis and alkalosis. Kasi pag sinabi nating acidosis, pag mas mababa sa 7.34 ang pH. Kasi diba, you learned in your hematology that the normal pH range of the blood that is 7.35 to 7.45. Okay? Tama ba? If you remember it. Okay. I'm so certain. Diba, naalala ko pa yan. College pa lang yan. Meron na yan. So, alam kong hima yan. Okay? So, that is 7.35 to 7.45. So, kapag mas mababa na siya sa 7.35, that is less than 7. Kasama na doon yung 7.34, that is classified as acidosis. Pero pag mas mataas na siya sa 7.46 or mas mataas na siya sa 7.45, that is known as alkalosis. So, we have further divisions of acidosis and alkalosis. Okay? Meron ulit yung division. We have the metabolic acidosis and alkalosis, also known as the non-respiratory acidosis or alkalosis. Meron din naman tayong respiratory acidosis and alkalosis, depending kung ano yung organ na may problem. Pag sinasabing non-respiratory acidosis or alkalosis, or other term, yung ibang book, old books kasi, they don't use the non-respiratory. Instead, they use the metabolic acidosis or alkalosis. Okay? Yung mga 6th edition pababa ni Bishop, ang term nila is metabolic. Okay? Pero pag sa 7th edition pataas, ang ginagamit nilang term is non-respiratory. That is for metabolic. Okay? So, ano ba yung pagkakaiba nun? So, depending on the cause of acidosis or alkalosis. Pag sinasabing respiratory acidosis or alkalosis, yung acidosis or alkalosis that is caused by an abnormality sa lungs. Kaya nga respiratory, di ba? Kasi when we say respiration, we are referring to the organ na lung. Pero pag sinasabi nating metabolic acidosis or non-respiratory acidosis or alkalosis, those are acidosis and alkalosis. That is not a problem with the lung. So, mostly dyan involved is si kidney. Okay? Sa metabolic acidosis, alkalosis. The reference value for arterial blood pH is 7.4. Okay? So, yan na yung tawag dito, pinakagitna, di ba, ng 7.35 to 7.45. And that is already equivalent to hydrogen ion concentration of 40 nanomole per liter. Because pH is the negative log in direct proportion, okay, of the hydrogen ion concentration. An increase in hydrogen ion concentration, ano ibig sabihin nun? An increase in hydrogen ion concentration, ano mangyayari sa pH? Guys, bababa yung pH kasi magiging acidic siya. Pero kapag mababa ang hydrogen ion concentration mo, anong mangyayari sa pH? Tataas kasi magiging alkaline. Nagigets? Diba? Magkaiba, hindi sila directly proportional. Okay? The arterial pH is controlled by the systems that regulate the production and retention of acids and bases. So, these include buffers, okay, lungs, and kidneys. So, buffer system, regulation of hydrogen ion concentration. Buffer systems are the body's first line of defense against extreme changes in hydrogen ion concentration. Kapag nagkakaroon ng extreme changes, dyan na mag-a-act yung mga buffer natin. Okay, again, what is the main buffer? That is the bicarbonate buffer system. All buffers consist of a weak acid. So, sa bicarbonate carbonic acid buffer system, okay, ang weak acid doon, that is the carbonic acid. Ang conjugate base naman dito is si bicarbonate. Ito yung base, ito yung weak acid, si carbonic acid. Okay? Nasa name naman niya, carbonic acid, that is a weak acid. Okay, so this is the carbonic acid. Carbonic acid is a weak acid because it does not completely dissociate into hydrogen and into bicarbonate. So when an acid is added to the carbonic acid system, the bicarbonate will combine with the hydrogen ion from the acid to form the carbonate. Okay? So para ma-maintain, for example, merong additional na acid sa katawan. Anong gagawin ni bicarbonate? Ito kasi yung conjugate base. So, magre-react na sila to form, magre-react siya, o magko-combine siya with the acid that is the hydrogen ion, magpo-form sila ng carbonic acid. Okay? So, magiging H2CO3 na siya. Pero kapag base naman ang nai-add, anong mangyayari? Okay? So, si H2CO3 or si carbonic acid will combine. Kasi diba ang base that is hydroxyl, that is represented by the hydroxyl. So, yung base, magko-combine siya sa carbonic acid to form water and the bicarbonate. Okay? So, ganun yung nangyayari. Kapag acid, kanino siya makikombine? Sa conjugate base. Kapag base naman ang naidagdag, saan siya makikombine? To the weak acid, that is the bicarbonate. Okay, in both cases, there is a smaller change in pH that would result from adding the acid or base to an unbuffered solution. Okay? Although the bicarbonate carbonic acid system has low buffering capacity, it is still an important buffer system for three major reasons. That is, carbonic acid dissociates into carbon dioxide and water, allowing carbon dioxide to be eliminated by the lungs and hydrogen ion as water. Okay? So changes in the carbon dioxide modify the ventilation. Excuse me, guys. Bicarbonate concentration can be altered by the kidneys. Okay? Ang hold kasi ni lungs, okay? So, yung pag-explain ko, mainly Filipino na or Tagalog para mas madali nyo maintindihan. Okay? Si lungs kasi, it balance, okay? Binabalance niya ang acid-base. It does or it maintains the acid-base balance by the use of hypoventilation or hyperventilation. That is either i-retain niya ang carbon dioxide or i-eliminate niya ang carbon dioxide through breathing. Okay? Si kidney naman, ang main na ginagawa niya to maintain acid-base balance, okay, that is to eliminate bicarbonate, okay, or to retain bicarbonate. So, yun yung pagkakaiba, di ba? Si lungs and si kidney, sila yung major organs for maintaining the acid-base balance. Ito, that is through elimination or retention. Si lungs, through elimination or retention ng carbon dioxide. Si kidney naman, that is through elimination or retention ng base na si bicarbonate. Okay, so other buffer system, the phosphate buffer system, plays a role in plasma and red blood cells and is involved in exchange of sodium ion in the urine. So that is for hydrogen ion filtrate. So plasma protein, especially the imidazole groups of histidine, also forms an important buffer system sa plasma. Okay, so other buffer system, plasma protein, and the phosphate buffer system. The lung and kidneys play play an important role in regulating the blood pH because they are the main organs involved in maintaining the acid-base balance in the body. So the HCO3 or the bicarbonate denotes the kidney function because this is the compound that is eliminated or retained by the kidney to maintain the acid-base balance, whereas this one is partial pressure of carbon dioxide, which means that the dissolved concentration of carbon dioxide in the blood. Okay? So the partial pressure of carbon dioxide, which represents the carbonic acid, denotes the lung function. Okay? So, ang lung function is through elimination or retention ng carbon dioxide. So, take note guys na si carbon dioxide, it represents the carbonic acid. So, kung si carbon dioxide, maraming na-eliminate na carbon dioxide, ibig sabihin din nun, maraming na-eliminate na hydrogen ng carbonic acid, which is the acid. Okay? So, kailangan nyo intindihin yun because that is very important in our discussion sa hypoventilation and hyperventilation. The lungs regulate pH through retention. Ito na yung sinasabi ko kanina, or elimination ng CO2 by changing the rate of ventilation. So, that is hypoventilation or hyperventilation. Si kidneys naman, main function niya is that to reclaim, okay, retention or elimination ng bicarbonate. So, other method wherein it can regulate pH is that by excreting acid primarily in the ammonium ion. But this is its main way of maintaining pH balance. Okay, so we have here regulation of acid-base balance, okay, sa lungs, okay, and in the peripheral tissue. Okay, so the carbon dioxide, okay, which is generated from metabolism, or that is the end product of most aerobic metabolic processes. So it easily diffuses out of the tissue or out of the cell, okay, where it is produced into the plasma and red cells in surrounding capillaries. Okay, so most of the carbon dioxide combines with water to form the carbonic acid. Okay, and then the carbonic acid quickly dissociates into hydrogen ion and into the bicarbonate. Okay. Okay, so this reaction, this is accelerated by the enzyme carbonic anhydrase. Okay, that is found in the red cell membrane. So the dissociation of the carbonic acid causes the bicarbonate concentration to increase in the red cells and diffuse into the plasma. Okay, so the dissociation also increases the bicarbonate. Okay, kasi nga, that is carbonic acid, pero nag-change na siya ng form into bicarbonate. So, tumataas yung level ng bicarbonate. So, to maintain the electron neutrality, when you say electron neutrality, the number of the positive and negatively charged ion outside the red cell membrane and inside the red cell membrane is equal. So, in that way, chloride diffuses into the cell. Okay? So, since lumalabas yung eto, di ba, magde-diffuse siya into this one, into bicarbonate and hydrogen ion. And eto, lalabas sila, si bicarbonate and then si hydrogen ion. Lalabas sila from the inside of the cell. To maintain the electron neutrality, papasok naman ngayon si chloride inside the cell. So, magkakaroon yun yung tinatawag na chloride shift. Okay? So, yung paglabas ni hydrogen ion, in the red cell membrane, papasok naman si chloride. Okay, that is known as the chloride shift. Plasma proteins and plasma buffers combine with the freed hydrogen ion to maintain a stable pH. Okay, so yun yung action ng mga plasma buffer. So kapag marami kasi ang hydrogen ion that is free in the system or in the blood, ano mangyayari? Mag-decrease ang pH kasi magiging acidic siya. So, to avoid that, makiki-combine ito sa mga buffer. Kasi nga si buffer, they will combine with either a base or an acid to resist a change in the pH. Okay? So, in the lungs naman, the process is reversed. So, the inspired oxygen diffuses from the alveoli into the blood and is bound to the hemoglobin. So, forming the oxyhemoglobin. The hydrogen, this one, the hydrogen that was carried on the reduced hemoglobin, okay, is released to combine with the bicarbonate. So it will bind with the bicarbonate, which dissociates into, so it binds with the bicarbonate forming carbonic acid, which then dissociates to form the carbon dioxide and the water. Okay? And in return, di ba, carbon dioxide is exhaled. As we inhale oxygen, carbon dioxide is exhaled. So the CO2 diffuses into the alveoli and is eliminated through the process of ventilation, okay, or the process of breathing. So nai-eliminate yung carbon dioxide in the lungs through the process of breathing. Okay? So the net effect of the interaction of these two buffering systems is a minimal change in hydrogen ion concentration between the venous and the arterial circulation. However, guys, when the lungs do not remove carbon dioxide at the rate of its production, kumbaga, mas maraming na-produce na carbon dioxide yung mga tissues natin. Pero mababa lang yung elimination. Possible na may damage yung lungs, or may hypoventilation, or low number of breathing, or decreased in breathing. So, in that case, anong mangyayari? Tataas yung level ng carbon dioxide sa katawan natin. Pag tumaas yung level ng carbon dioxide, ibig sabihin, tataas din yung level ng carbonic acid. Okay? So, tataas yung acid kapag mataas ang carbon dioxide sa katawan. So, anong mangyayari in that way? Anong mangyayari, guys? Bababa ang pH. So, pag bababa ang pH, anong mangyayari? Magiging acidic. Okay? However, guys, vice versa, kapag sobrang bilis naman ng removal ng carbon dioxide, okay, kagaya ng hyperventilation, okay, increased breathing, or increased deep breathing, sobrang mabilis yung paghinga and sobrang lalim, so maraming carbon dioxide ang nai-eliminate. Ano naman yung mangyayari in that case? So, since sobrang daming carbon dioxide ang mai-eliminate, okay, so, anong mangyayari sa, sorry, medyo nawalan ako. Hindi. Anong mangyayari sa pH? Okay? Anong mangyayari sa pH? Tataas. Okay? Tataas. So, magiging, na siya? Anong mangyayari? Magiging alkaline. Magkakaroon ng alkalosis. Okay? So, in that way, anong mangyayari sa hydrogen ion concentration? Kapag may hyperventilation, okay, so it follows then with the concentration ng hydrogen ion. Kapag hyperventilation, okay, sobrang daming carbon dioxide ang nai-eliminate. Okay? Ano ulit yung nangyayari? Nagiging alkaline. So, in that way, nagiging alkaline siya. Bumababa yung level ng hydrogen ion concentration. Okay? Bumababa yung hydrogen ion concentration, kaya nagiging alkaline. Nakukuha kasi nga maraming acid yung nai-eliminate. Pero kapag may hypoventilation naman, anong nangyayari? Maraming CO2 ang nare-retain. Tumataas yung level ng hydrogen ion concentration. Bumababa yung acidity, kaya mas nagiging acidic. So, I hope na-gets niyo. Okay? The lungs, by responding within seconds together with the buffer systems, provide the first line of defense to changes in the acid-base status. So, yung mga sinabi ko naman, it's here. Sinend ko naman na PowerPoint presentation. Okay? So, in-explain ko lang siya. Okay, the kidneys are also able to excrete variable amounts of acids or base, making them an important player in the regulation of acid-base balance. The kidney's main role in maintaining acid-base homeostasis, that is to reclaim bicarbonate from the glomerular filtrate. So, yung main mode niya, that is actually retention. Retention ng bicarbonate. Okay? Yun yung pinaka-main na way or process ni kidney to maintain the acid-base balance. Without this reclamation or retention, okay, the loss of bicarbonate in the urine would result in an excessive acid gain in the blood. Kasi nga this is base. So kapag sobrang dami ang na-loss mo na base, ano mangyayari sa acid? Sobrang dami yung acid. So pag sobrang dami yung acid, ano mangyayari? Maraming hydrogen ion concentration. Then ano mangyayari sa acidity? Magiging acidic siya. So that will lead to acidosis. The main site for bicarbonate reclamation is the proximal tubules. The glomerular filtrate contains essentially the same bicarbonate levels, just the same with the plasma. So the process is not a direct transport of bicarbonate across the tubule membrane into the blood. Instead, sodium in the glomerular filtrate is exchanged for hydrogen ion in the tubular cell. So, nagkakaroon pa rin siya ng exchange. Sodium ion exchange to hydrogen ion. So, the hydrogen ion combines with bicarbonate to form, again, i-combine mo lang siya. So, magiging H2CO3. So, magiging carbonic acid na siya, which is converted into water and into carbon dioxide by the carbonic anhydrase. The carbon dioxide easily diffuses into the tubule and reacts with the water to reform. Okay, so parang pabalik-balik lang. Magre-reform siya into into carbonic acid and then magde-diffuse ulit into bicarbonate, which is reabsorbed into the blood along with the sodium. So, with alkalotic conditions, okay, in alkalosis, yun yung ibig sabihin niya, the kidneys excrete, okay? So, since alkalosis na ibig sabihin mataas na yung pH level kasi masyadong maraming base. Okay? So, anong gagawin ni kidney? Kidney will excrete the bicarbonate, which is the base, to compensate for the elevated blood pH. Okay? So, kung alkalosis na mataas yung level ng bicarbonate, mataas yung level ng base, ang gagawin ni kidney is to eliminate some of the base para mabalance yung pH. The exchange between the hydrogen ion and the sodium ion suggests in part why clinicians order pH and blood gases together along with electrolyte, sodium, potassium, and chloride to assess the patient. Okay, various factors affect the reabsorption of the bicarbonate. So, when the blood or plasma bicarbonate level is higher than 26 to 30, so bicarbonate will be excreted. So, if that is already greater than 26 millimole per liter na bicarbonate, mag-start na yung elimination or excretion ng bicarbonate. So, it is unlikely that the plasma will exceed bicarbonate value of 30 millimole per liter unless these excretory capabilities, unless these excretory capabilities fail. Kagaya na lang kapag merong kidney failure. So, in that way, kahit sobrang taas ng level ng bicarbonate, pero may problem naman sa excretion kasi may problema yung kidney, hindi mai-eliminate ang bicarbonate. So, however, a frequent exemption to this is compensatory retention of the bicarbonate in chronic hypercarbia, as in with chronic lung disease. So, anong ibig sabihin nito, guys? So, kahit lumagpas na, exemption dito, kahit lumagpas na sa 30 millimole per liter, okay, in chronic hypercarbia, there is still retention or kinikip niya pa rin yung bicarbonate kahit mas mataas na yung level niya sa 30 millimole per liter. Okay? The bicarbonate level may increase if an excessive amount of lactate, acetate, or bicarbonate is intravenously infused. Okay? So, kapag may ini-inject sila na lactate, acetate, or bicarbonate, tumataas yung level ng bicarbonate. It may also increase if there is an excessive loss of chloride. Okay? Without replacement. So, kapag may sweating, okay? Sweating, vomiting, and prolonged nasogastric suction, tumataas yung bicarbonate level because the bicarbonate will be retained by the tubule to preserve electroneutrality. Okay? So, since this is also um, an anion. Anion siya. So, nai-eliminate yung anion na chloride para ma-maintain yung electroneutrality. I-retain ni body yung other anion. Okay? So, that is bicarbonate. Okay? So, kapag nagkakaroon ng increased loss of chloride, retention of bicarbonate will happen to maintain electroneutrality. Okay, factors resulting to decrease bicarbonate level. Kanina, increased bicarbonate level. Ngayon naman, decreased bicarbonate level. So, most diuretics, regardless of the mechanism of action, it favors the excretion of bicarbonate. So, diuretics will result to decreased bicarbonate level. Reduced bicarbonate reabsorption also occurs in conditions in which there is an excessive loss of cation. So, kapag sobrang daming nawawala or na i-excrete na cation, bumababa din yung level ng bicarbonate. In kidney dysfunction, kagaya na lang sa chronic nephritis or infection, bicarbonate reabsorption is impaired. So, nag-increase yung excretion, okay? Or hindi nagpa-function well yung kidney, kaya hindi nag-i-stay yung bicarbonate. So, ano mangyayari? Magde-decrease yung level ng bicarbonate. Assessment of acid-base homeostasis. For the bicarbonate buffering system, the dissolved carbon dioxide is in equilibrium with the carbon dioxide gas, which can be expelled by the lungs. Therefore, the bicarbonate buffering system is referred to as an open system, and the dissolved carbon dioxide, which is controlled by the lungs, is the respiratory component. So, respiratory component dito is the carbon dioxide. Kasi yun nga yung main na compound na ini-eliminate or kinikip niya in the hypoventilation or in the hyperventilation. The lungs participate rapidly in the regulation of blood through hypoventilation or hyperventilation. Si kidney naman, the non-respiratory or formerly known as metabolic component, okay, control the bicarbonate concentration. Okay? So, dyan na pumapasok yung sinasabi ko kanina na respiratory acidosis alkalosis and metabolic acidosis alkalosis. Pag metabolic yun, yung older books kasi, yun yung non-respiratory metabolic acidosis or alkalosis. Okay? So, lungs regulate blood pH through any of these two, hypoventilation or hyperventilation. Kidneys naman, it maintains or it regulates blood pH through what, guys? The control of bicarbonate concentration. Okay, so we proceed with acid-base disorders. This is acidosis and the alkalosis. So this is just an introduction kasi meron pang further discussion si Henry. So yun yung recorded discussion sa part 2. Okay, acidosis and alkalosis, pag sinabi nating acidemia, okay, if the blood pH is less than the reference range. Okay? So, kapag acidemia, anong level, ano yung concentration ng hydrogen ion? Mataas ba or mababa? Increase or decrease? That is increased. Okay? Excess or increased acid or hydrogen ion concentration. Kasi nga negative log, indirectly proportional siya sa pH. Kapag mababa yung pH mo, ibig sabihin mataas or excess ang hydrogen ion concentration. Pag mataas ang pH mo, ibig sabihin nun mababa ang hydrogen ion or acid concentration mo. Gets? The pH greater than reference range is termed as alkalemia. Okay? Or excess base. So, kapag nire-refer natin na excess base, that is alkalemia. Masyadong or alkalemia, that is mababa yung concentration ng hydrogen ion. So, a disorder caused by ventilatory dysfunction, a change in partial pressure of carbon dioxide. The respiratory component is termed as primary respiratory acidosis or alkalosis. In older books, what you will see is respiratory acidosis or respiratory alkalosis. Anong ibig sabihin nito, guys? Kapag yung lungs ang may problema or dun sa ventilatory, there is ventilatory dysfunction, okay? Magre-result yan into either respiratory acidosis or alkalosis. Okay? Yun yun. Yun yung ibig sabihin niya. Kapag si lungs ang may problema, respiratory acidosis or alkalosis. Kapag lungs ang may problema, okay, ang compensatory mechanism or compensation niya is through the kidneys. Okay, baliktad. Pero kapag si kidneys ang may problema in metabolic acidosis or alkalosis, also known as the non-respiratory acidosis or alkalosis, ang compensation mechanism is the lungs. Gets? Pag ang problema si lungs, ang mag-a-act for compensatory mechanism si kidney. Pag si kidney ang may problema, ang mag-a-act into compensatory mechanism is si lungs. Nakukuha? Okay, a disorder resulting from a change in bicarbonate level, a renal or metabolic function, is termed as non-respiratory disorder. Okay? So mixed respiratory and non-respiratory disorders occasionally arise from more than one pathologic process and represent the most serious of medical conditions as compensation for primary disorder is failing. Okay, because the body's cellular and metabolic activities are pH dependent, the body tries to restore acid-base homeostasis whenever an imbalance occurs. Okay, so this action by the body is termed as compensation. Okay, the body accomplishes this by altering the factor not primarily affected by the pathologic process. That's why, guys, if the problem lies with the lungs, the kidneys will act as the compensatory organ. But if the problem lies with the kidney, the compensatory organ will be the lungs. Okay? So, yun yung compensation na sinasabi ko kanina pa. That is the body's way to maintain the acid-base balance. Okay? For example, if an imbalance is of non-respiratory origin, non-respiratory, hindi lungs, okay, possible na kidney, possible na other parts of body, the body compensates by altering ventilation. Okay? So, since dalawa lang kasi yung major organ that maintains acid base, okay, kung non-respiratory na yan, ang mag-a-act for compensation, compensatory mechanism, si lungs. Okay, paulit-ulit tayo doon for you to understand it well. Okay? Pero kapag ang problem mo naman si lungs, since ang problema nasa kay lungs, ang mag-a-act is the kidney. Okay? So, ano ba yung method of regulating acid-base balance by the lungs? Two ways. Either hypoventilation or hyperventilation. Okay, for disturbances of the respiratory component, that is the lungs, the kidneys compensate by selectively excreting or reabsorbing anions and cations, particularly the bicarbonate. The lungs can compensate immediately, but the response is short-term and often incomplete. Mas mabilis si lungs, mas short-term nga lang, and incomplete siya. Unlike kay kidneys, mas matagal. Okay? The kidneys are slower to respond, 2 to 4 days, however, but the response is long-term and potentially complete. Okay? Fully compensated implies that the pH has returned to a normal range. The 20:1 ratio has been restored. Normally kasi guys, ang ratio ng bicarbonate into carbonic acid, that is 20:1. So, yun yung tinatawag na fully compensated. Normal na ulit yung ratio ng bicarbonate into carbonic acid, that is 20:1. Partially compensated implies that the pH is still approaching the normal range. Okay? While compensation may successfully return the ratio to a normal 20:1, that is bicarbonate to carbonic acid, the primary abnormality is not corrected. Okay? Like for example, merong emphysema or chronic obstruction in the obstruction in the lungs. Okay? I-maintain ngayon ni kidney. Okay? The kidney will regulate the acid-base balance. Okay? Even if it has successfully regulated the acid-base balance, it doesn't mean na makokorek na din yung problem sa lungs. Yun yung ibig sabihin ng sentence na to. Acidosis may be caused by a primary non-respiratory abnormality or by a primary respiratory problem. Okay? So, either metabolic siya or respiratory siya. Okay? So, in primary non-respiratory acidosis, ito yung other books, they term this as metabolic acidosis. Okay, there is a decrease in bicarbonate, so less than 24 millimole per liter, resulting in a decreased pH as a result of the ratio of the non-respiratory to respiratory component in the Henderson-Hasselbalch equation being less than 20:1. Okay? Kapag acidosis kasi yan, non-respiratory origin or metabolic acidosis, ibig sabihin nun, mababa yung level ng bicarbonate. Okay? So, nagiging acidic siya kasi nga sobrang konti ng base. Yun yung sa non-respiratory acidosis. Nagigets? Bakit nagkakaroon ng respiratory o metabolic acidosis? Kasi mababa yung base. Okay? There is a decrease in bicarbonate. And si bicarbonate, ito yung base natin. Gets? Okay, non-respiratory acidosis or metabolic acidosis. Actually, guys, the term metabolic acidosis, yun yung dating ginagamit. Pero pinalitan na siya into non-respiratory acidosis. However, if you encounter books by Henry, I don't know if the latest edition also uses the term non-respiratory. Pero yung mga old edition kasi ang gamit is metabolic acidosis. Okay? So, even for Bishop, baka kasi old Bishop yung gamit nyo, ang term kasi niya doon is metabolic acidosis. Kaya, nuulit-ulit ko na non-respiratory acidosis / metabolic acidosis. Okay? So, non-respiratory acidosis or metabolic acidosis may be caused by a direct administration acidosis. So, ibig sabihin yan, mataas ay acidosis that is metabolic or non-respiratory in origin, mababa yung level ng bicarbonate or there is a decreased bicarbonate. That can be caused by a direct administration of acid-producing substance such as ammonium chloride, calcium chloride, or by excessive formation of organic acids as seen with diabetic ketoacidosis and starvation. In diabetic ketoacidosis, guys, mataas dyan, diabetic, ibig sabihin, mataas pa rin yung level ng kanyang sugar. Okay? Mataas yung level ng kanyang sugar. Okay? Mababa yung pH kasi nga acidosis. And then, there are the presence of ketone bodies. Okay? May mga ketone bodies. Kaya diabetic ketoacidosis. And starvation. So, in these cases, guys, that may lead to non-respiratory acidosis / metabolic acidosis kasi nga there is a decreased bicarbonate concentration and an increase, because of this one, itong mga cases na to, increased concentrations of the acid. Okay? Increased concentration of the acid, decreased concentration of the bicarbonate. Non-respiratory acidosis is also seen not only in these cases but also seen with reduced excretion of acid. So, kung mababa yung na-excrete na acid, ano mangyayari sa acid? Mag-accumulate. So, pag nag-accumulate, ano mangyayari doon? Magkakaroon ng acidosis. Kagaya na lang ng renal tubular acidosis, that may also lead to non-respiratory acidosis, and with excessive loss of bicarbonate. So, kapag sobrang daming na-eliminate na bicarbonate, anong mangyayari sa balance? Acid-base balance. Maraming natanggal na base, maraming naiwan na acid, acidosis yung mangyayari. Okay, with excessive loss of bicarbonate from diarrhea or drainage from a biliary, pancreatic, or intestinal fistula. So, these cases would result to non-respiratory acidosis or metabolic acidosis. Okay, so in this case, non-respiratory acidosis or metabolic acidosis. Okay, so the problem lies with the kidney. So the compensatory mechanism is done by the lungs. Okay, since acidic na siya, okay, kumbaga acidic na yung katawan mo, anong gagawin ni lungs? Hyperventilation ba or hypoventilation? Ikikip ba niya yung carbon dioxide or i-eliminate niya ng mabilisan ang carbon dioxide? Since acidic na yung environment, pabibilisan na ni lungs yung elimination ng carbon dioxide. Okay? So, in that way, magkakaroon ng hyperventilation. The body compensates for non-respiratory acidosis through hyperventilation, which is an increase in the rate or depth of breathing by blowing off carbon dioxide. So, the acid to the base to acid ratio will return toward normal. Okay, so that is the compensatory mechanism for non-respiratory acidosis or metabolic acidosis. Okay, secondary compensation occurs when the original organ, okay, so just like in this case, the kidneys begin to correct the ratio by retaining bicarbonate. Okay, so if it can still do its function. Okay, so primary na compensatory mechanism niya yung lungs. Okay, secondary si kidney. Okay, kanina, that is non-respiratory or metabolic acidosis. Ngayon naman, we will discuss primary respiratory acidosis. Kanina, yung problema natin is other parts of the body that is not the lungs. Pwedeng si kidney, pwedeng other parts. Okay? Dito naman, ang problema lies with the lungs. Kaya nga siya respiratory acidosis. Okay? In this case naman, it results from a decrease in alveolar ventilation. Okay? So, merong hypoventilation. Yung hypoventilation na yun, yung cause kung bakit nade-decrease yung elimination ng carbon dioxide by the lungs. Nakukuha? So, since mababa yung breathing rate, okay, mabagal yung pag-breathe, anong nangyayari sa carbon dioxide? Retention. Nag-i-stay ang carbon dioxide sa katawan. Kapag sobrang daming carbon dioxide sa katawan, ano mangyayari? There will be an increase in hydrogen ion concentration. So, kapag nag-i-increase ang hydrogen ion concentration, ano mangyayari sa pH? Bababa. Kaya magiging acidosis siya. So, hypoventilation, okay, if there's a decrease in alveolar ventilation or hypoventilation, that may lead to respiratory acidosis. So respiration is regulated in the medulla of the brain. So chemoreceptors present in the aortic arc and the carotid sinus responds to the levels of hydrogen or pH, oxygen, carbon dioxide in the blood, and the CSF. There are several situations including lung diseases in which carbon dioxide is not effectively removed from the blood. So if carbon dioxide is not effectively removed in the blood, what will happen to the level of carbon dioxide? It will increase. Together with the hydrogen ion concentration, it will also increase. So in that way, that leads to, again, what? Metabolic disorder, that is respiratory acidosis. Okay? Okay, in certain patients with COPD, okay, ibig sabihin, okay, or it stands for chronic obstructive pulmonary disease. Okay, destructive changes in the airways and alveolar walls increase the size of the alveolar air spaces with the resultant reduction of lung surface area available for gas exchange. Which means, guys, that in COPD, okay, the alveolar walls is already decreased. The alveolar walls that can be used for gas exchange is decreased. Okay? Kumukonti na yung wall wherein the gas exchange may happen. So, as a result, CO2 is retained. Okay? CO2 is retained in the blood causing chronic hypercarbia or elevated level of partial pressure of carbon dioxide or dissolved carbon dioxide. Okay? Kaya in COPD, since hindi na nangyayari yung, though it happens, but decreased yung elimination ng carbon dioxide, what will happen? That will lead to acidosis. Since this is a problem of the lungs, that is respiratory acidosis. Okay? And that may lead to chronic hypercarbia because of the high level of dissolved carbon dioxide. Okay? Kasi nga, hindi siya well eliminated. In bronchopneumonia, gas exchange is impeded. Okay? Kanina, reduced yung alveolar walls for gas exchange. This naman, in bronchopneumonia, gas exchange is impeded because of the secretions, white blood cells, bacteria, and fibrin in the alveoli. Kumbaga, there is a wall. Okay? May naghihinder ng gas exchange. So, Hypoventilation, in this case also, that results to increased level of dissolved carbon dioxide in the blood, resulting to respiratory acidosis. Hypoventilation caused by drugs such as barbiturates, morphine, alcohol will also increase blood PCO2 levels, as well mechanical obstruction or asphyxiation. Okay? So kapag may sinakal, strangulation, that can also lead to hypoventilation kasi hindi ka na nga makakahinga. Diba? So kung hindi ka makakahinga ng maayos, there's hypoventilation, decrease in breathing. Okay? So, the elimination of carbon dioxide is impeded. So, anong mangyayari? Mag-i-increase yung blood PCO2 level. Okay? So, guys, I hope nagigets nyo yun. Napapagtagpi-tagpi nyo siya. Okay? Decreased cardiac output such as that seen with congestive heart failure. Okay? Will also result in less blood being presented to the lungs for gas exchange and therefore an elevated PCO2. Okay? So, in congestive heart failure, the problem is that less blood is being presented in the lungs. Okay? In the lungs for gas exchange. Though, ang problem dito is not the lungs, okay? This still leads to respiratory acidosis. Kasi nga, yung main problem na dito, okay, kung bakit siya nagkakaroon ng respiratory acidosis is because of the less gas exchange that occurs. Nade-decrease yung gas exchange because of the decrease in the blood that is being presented to the lungs. Okay? So, anong mangyayari? Since konti lang yung ipresent na blood, konti lang nade-decrease yung elimination ng carbon dioxide, that leads to increased level of PCO2, leading to decreased level ng pH. Okay? Mataas na PCO2, magde-decrease ng pH kasi nga magiging acidic siya. Okay? In primary respiratory acidosis, the compensation occurs through non-respiratory process. That is through the kidney. Okay? So that is through the kidney. The kidney increase the excretion of hydrogen ion and increase the reclamation or retention of bicarbonate. Okay? Bakit kailangan niyang i-excrete ang hydrogen ion? Kasi diba, this is an acid. Okay? So, meron kang respiratory acidosis, acidic na. So, anong gagawin ni kidney? I-eliminate niya yung acid. Okay? That is in the form of hydrogen ion. Okay? To balance the acid base. I-eliminate niya yung hydrogen ion, i-keep niya yung bicarbonate para ma-balance, okay? Magkaroon ng acid-base balance. Although the renal compensation begins immediately, it takes 2 to few weeks for maximal compensation to occur. When the bicarbonate in the blood increases as a result of action of the kidneys, the base to acid ratio will be altered and the pH will return toward normal. Okay? So, take note of that, guys. Okay, as with acidosis, alkalosis can result from non-respiratory or respiratory causes. So, either metabolic or respiratory causes. Primary non-respiratory alkalosis results from a gain in bicarbonate. If you remember, the primary non-respiratory acidosis results from loss of bicarbonate. Kaya siya nagiging acidic because of the loss of bicarbonate. In non-respiratory alkalosis naman, it results from the gain of bicarbonate. So, ibig sabihin, nagiging ng bicarbonate, maraming bicarbonate, kaya nagiging alkalosis, causing an increase in the non-respiratory component and pH. Okay, so tumataas yung pH pero mababa yung acidity. Okay, mababa ang hydrogen ion concentration. This condition may result from the excess administration of sodium bicarbonate or through ingestion of bicarbonate producing salts such as sodium lactate, citrate, and acetate. Excessive loss of acid through vomiting, nasogastric suctioning, or prolonged use of diuretics that augment renal excretion of hydrogen ion concentration can produce an apparent increase in bicarbonate. So the body responds by depressing the respiratory centers. Since this is non-respiratory origin, yung compensatory mechanism niya, that is done by the lungs. The resulting hypoventilation increases retention of carbon dioxide. So remember, this is non-respiratory alkalosis. Okay, this is non-respiratory alkalosis wherein there is an excess bicarbonate. So, if there is an excess bicarbonate, what will the body do to maintain the balance? So, that is, it will use the lungs. So, this will, what guys, hyperventilation or hypoventilation? Will it increase the excretion of carbon dioxide or will it retain the carbon dioxide? So, to maintain, since meron kang excess base, to maintain or to balance the acid base, that is also to maintain or not to excrete carbon dioxide. Okay? Ikikip niya yung carbon dioxide para may mag-balance dun sa excess na bicarbonate. So, hypoventilation, yung main compensatory mechanism ng non-respiratory alkalosis. Okay? That is, hypoventilation increases the retention of carbon dioxide so that it can balance the excess amount of bicarbonate. Primary respiratory alkalosis from an increased rate of alveolar ventilation causes excessive elimination of carbon dioxide by the lungs. Kanina, di-discuss natin yung non-respiratory alkalosis or metabolic alkalosis. Ngayon naman, we go to respiratory alkalosis. In respiratory alkalosis, there is increased elimination ng carbon dioxide. Okay? So, if increase yung elimination ng acid in the form of carbon dioxide, ano mangyayari? Okay? So, mababawasan yung acid, magiging imbalance, magiging alkaline siya, kaya nagiging respiratory alkalosis. So, this one, primary respiratory alkalosis, this is a consequence of hyperventilation. Okay, increased rate of alveolar ventilation. Si primary respiratory acidosis, that is caused by hypoventilation. Kasi nga, nagiging acidic kasi nakikip ang carbon dioxide. Dito naman, naging alkalosis kasi nga, excessive yung elimination ng acid. Okay? In the form of the carbon dioxide by the lungs. Okay? Sa lungs yan, kaya respiratory. The causes of respiratory alkalosis include hypoxemia, chemical stimulation of the respiratory center by drugs such as salicylates, an increase in the environmental temperature, fever, hysteria or hyperventilation, pulmonary emboli, and pulmonary fibrosis. So, these factors leads to respiratory or primary respiratory alkalosis. So, the kidneys compensate since the problem here lies with the lungs. The kidneys will do the compensatory mechanism. Excuse me. The kidneys compensate by excreting bicarbonate in the urine. Okay? Since this is alkalosis, ibig sabihin alkaline. Okay? So, anong gagawin ni kidney? That is to eliminate a base. So, i-eliminate niya ngayon ang bicarbonate. So, it compensates by excreting bicarbonate in the urine and reclaiming hydrogen ion to the blood. The popular treatment for hysterical hyperventilation, breathing into a paper bag is self-explanatory. Okay. In hysterical hyperventilation, di ba, pinapa-breathe nila yung isang individual within a paper bag, okay, or within in a plastic bag. So, bakit ganun guys? Kasi diba in hyperventilation, there's an increased elimination of the carbon dioxide. So, to keep that carbon dioxide, yung ini-eliminate or bini-breathe out ng isang individual with hysterical hyperventilation is that it will also use, okay, kung ano yung bring it out niya na carbon dioxide, i-breathe in din niya para ma-maintain yung acid-base balance. Okay, yun yung ibig sabihin nun. Okay, oxygen and gas exchange, and oxygen and carbon dioxide. Evaluation of a patient's oxygen status is possible using partial pressure of oxygen measured along with pH and the partial pressure of carbon dioxide in blood gas analysis. So in blood gas analysis, guys, the sample here is arterial blood. Okay? Kaya nga meron yung term na arterial blood gas analysis kasi ang ginagamit talaga doon is the arterial blood. So, before I forgot, in the collection, okay, in the collection of the arterial blood gas, the sample must not be exposed to air. Okay? So, hindi dapat, for example, tinakpan na yan, nakalagay na siya sa tube, hindi mo dapat i-expose yung sample into an open air o hindi mo dapat tanggalin yung takip niya. Okay? Take note, guys, that the environment, it has a higher concentration of oxygen as compared to the oxygen that is present dun sa sample mo. So, kapag tawag dito, kapag in-expose mo yung sa sample mo into the environment, okay, ano mangyayari? So, may expose siya into a high concentration of oxygen. Ano mangyayari sa PO2 ng sample? Tataas yung partial pressure of oxygen ng sample. Okay? And magi-escape naman yung CO2 sa sample papunta sa environment. Okay? So, bababa ngayon yung concentration ng wait. So, bababa ngayon yung concentration ng PCO2 mo. Kasi nga, mag-escape yung carbon dioxide from your sample papunta sa environment. Kasi mas konti yung carbon dioxide sa environment as compared dun sa sample mo. So, in that case, since nade-decrease yung PCO2 mo, okay, mag-increase yung pH. Okay, so mag-increase yung pH together with the partial pressure of oxygen. On the other hand naman, kapag meron kang sample and you left that for some period of time, okay, proper collection was done, you did not open, you did not expose the sample into an open air, okay, nakatakip siya, pero iniwan mo siya ng matagal, anong mangyayari? Okay, so metabolism of the red blood cell will continue to happen. So, in that case, tataas naman yung PCO2 mo. Okay? Tataas yung PCO2 as a result of metabolism. Pag tumaas yung PCO2, okay, ano mangyayari naman sa oxygen? Sa partial pressure or dissolved oxygen dun sa sample mo na iniwan mo lang doon na nakatenga, bababa siya kasi nga gagamitin siya ng mga red blood cell for metabolism. Okay? So, in that case, since tumaas yung PCO2 mo, ano naman yung mangyayari sa pH? Okay? Bababa yung pH. Okay? Kapag iniwan mo lang yung specimen mo. Okay? Baka kasi hindi ko siya ma-discuss. Okay, there are 7 conditions necessary for adequate tissue oxygenation. That is, available atmospheric oxygen, adequate ventilation, gas exchange between lungs and arterial blood, loading of oxygen onto hemoglobin, adequate hemoglobin, adequate transport, release of oxygen to tissue. Any disturbances of these 7 conditions can result to poor tissue oxygenation. Okay, so 3 other factors, air that influence the dissolved or partial pressure of oxygen in the alveoli. That is the percentage of oxygen in inspired air, okay, or inhaled air, the amount of carbon dioxide in the expired or exhaled air, the ratio of the volume of inspired air to the volume of the dead space. Okay, so there are also factors that can influence the amount of oxygen that moves through the alveoli into the blood and then to the tissue. That is the destruction of alveoli, pulmonary edema, airway blockage, inadequate blood supply, and diffusion of carbon dioxide and oxygen. So, we explain the 7 factors or conditions necessary for adequate tissue oxygenation. Okay. Ay, hindi pala. These are the factors that can influence the amount of oxygen. So, number one, that is destruction of alveoli. So, if the alveoli, if there is destruction of alveoli, just like in emphysema, there will be an inadequate amount of oxygen that will move to the blood. Okay? Kasi nga, because of poor tissue oxygenation, kasi nasira na siya, nasira yung alveoli, kahit humihinga ka or you are inhaling air, the oxygen that you inhaled will not be properly absorbed by the alveoli. Okay? In pulmonary edema naman, gas diffuses from the alveoli to capillary through a small space. With pulmonary edema, fluid leaks into this space, increasing the distance between the alveoli and capillary walls and causing a barrier to diffusion. So, there is a barrier to diffusion because of the presence of the fluid. Kaya, madedecrease din yung oxygen delivery to the capillary walls. Airway blockage. Airways can be blocked, preventing the air from the atmosphere from reaching the alveoli. Asthma and bronchitis are more common cause of this type of problem. So, since there is airway blockage, you cannot properly inhale oxygen. So, the oxygen from the atmosphere cannot freely, okay, go into your lungs and it cannot just diffuse to the capillary wall. So, nagde-decrease din siya. Inadequate blood supply. When the blood supply to the lungs is inadequate, oxygen enters the blood in the lungs, but not enough blood is being carried away to the tissue where it is needed. So, this may be a consequence of a blockage of a pulmonary blood vessel, kagaya ng pulmonary embolism, pulmonary hypertension, or a failing heart. So, diffusion of carbon dioxide and oxygen. Because oxygen dioxide diffuses 20 times lower than carbon dioxide, it is more sensitive to problems with diffusion. Structural or physiologic alterations of the alveolar capillary bed impair oxygen uptake with minimal alteration of carbon dioxide excretion. This type of hypoxemia is generally treated with supplemental oxygen. But guys, take note that the percentage of oxygen must be increased temporarily when needed. Okay? However, 60% or higher oxygen concentration is already toxic. Okay? Or must be used with caution because it can be toxic to the lungs. Okay, oxygen transport. Most oxygen in the arterial blood is transported to the tissue by hemoglobin. So, si adult hemoglobin, it can carry up to 4 molecules. Diba? If you remember, 4 molecules, it has 4 rings. Okay, kung naalala nyo yung ion, meron din siyang 4 ion. 4 lang ba yun? I forgot. Yes, di ba? Nasa gitna yung ion. Pero, that's why it can carry 4 oxygen. So, the actual amount of oxygen loaded into hemoglobin depends on the availability of oxygen, concentration of type and type of hemoglobin. What are the different types of hemoglobin? Oxyhemoglobin, deoxyhemoglobin, sulfahemoglobin, methemoglobin, okay, carboxyhemoglobin, presence of interfering substances, kagaya ng carbon monoxide, which is 200 times. Okay, the affinity of carbon dioxide is 200 times higher as compared to the affinity of oxygen to the hemoglobin. Temperature of the blood and the levels of partial pressure of carbon dioxide and the 2,3-diphosphoglycerate or the 2,3-DPG. With adequate atmospheric and alveolar oxygen available and normal diffusion of oxygen to the arterial blood, more than 95% of functional hemoglobin will bind to oxygen. Increasing the functional hemoglobin further saturates the hemoglobin. However, once the hemoglobin is 100% saturated, when it carries 4 molecules of oxygen, an increase in O2 to the alveoli serves only to increase the concentration of distilled oxygen in the arterial blood. So, prolonged administration of high concentration of oxygen may cause oxygen toxicity and in some cases, decreased ventilation that leads to hypercarbia. So, normally, hemoglobin exists in one of 4 conditions, oxyhemoglobin, hemoglobin with oxygen, deoxyhemoglobin, okay, that is the reduced hemoglobin, so wala na siyang oxygen, carboxyhemoglobin, if it has, instead of carrying oxygen, it carries carbon monoxide and methemoglobin if the iron is in ferric state instead of the ferrous state. Okay, so that's for the part 1. For the second part, this is a further discussion of the acid-basis order. Yun nga yung mga na-discuss na din kanina, yung mga na-introduce kanina, metabolic acidosis and alkalosis, and respiratory acidosis and alkalosis.